Welcome aboard this short guide to LNG maritime safety, where we'll explain how carriers transport methane at minus 162 degrees Celsius and why that matters. Think of these ships as high-tech thermoses. Extreme temperatures make the cargo both powerful and hazardous, so the industry layers engineering, procedures, and trained crews to keep everything safe at sea. Meet the cargo. Liquefied natural gas is simply methane chilled until it shrinks roughly 600-fold, which is what makes ocean transport practical. That same cold creates brittle materials and frostbite risks, while vapors can form flammable clouds in a narrow concentration range. So, understanding both the cryogenic and flammability behaviors is essential to managing risk. The first line of defense is the ship itself, using two common containment approaches: robust, self-supporting spherical tanks, those golf balls on deck, and membrane-style insulated tanks integrated into the hull. Both sit behind a double hull and heavy insulation, so physical impacts, sloshing forces, and thermal leaks are resisted by multiple structural layers before any cargo can escape. Safety is also built into sensors and systems that act faster than human reaction alone. Arrays of electronic noses monitor methane, inert gas blankets prevent a flammable atmosphere from forming, and an emergency shutdown system can instantly isolate cargo flow. Combined with explosion-proof electrical design, these automated controls catch problems long before they become emergencies. Fighting an LNG fire requires science, not a garden hose. Applying warm water to cryogenic fuel simply increases vaporization and fuels the blaze. Effective responses use dry chemical agents to interrupt combustion and targeted water sprays to cool nearby structures, along with containment tactics that limit vapor spread and protect responders from radiant heat. Technology provides tools, but people supply judgment. Advanced training, realistic drills, and virtual reality practices sharpen the crew's skills, while competence, a strong safety culture, and an international regulatory framework ensure decisions under pressure are sound. The human element remains the critical final armor, able to interpret systems and act when situations deviate from the expected. Think of LNG safety as the Swiss cheese model. No single barrier is perfect, so multiple independent layers are stacked. Robust vessel design, engineering controls like gas detection and ESD systems, clear procedures for response, and human competence. An accident only happens if the holes in every layer line up, which is why redundancy and learning are so important. The future of this layered armor is smarter systems that anticipate problems. Predictive maintenance uses AI and sensor data to forecast failures before they occur. Autonomous robotics reduce human exposure in hazardous areas, and augmented reality helps crews pinpoint tiny leaks and follow procedures hands-free, all improving risk reduction and predictive capability aboard vessels. The record speaks for itself. LNG shipping has maintained an exceptionally low rate of major cargo incidents over decades, and that safety comes from continuous learning rather than luck. The industry analyzes near misses, refines procedures, embeds lessons into training, and implements design changes, creating a resilient cycle of improvement across the global fleet. In short, managing an LNG carrier is more like operating a space station on the ocean than driving a truck. It's an extreme environment managed through integrated engineering, rigorous procedures, and deeply trained people. When those elements work together, the dangerous thermos becomes one of the most sophisticated and reliable ways to move energy around the world.